at the bottom of this box, it has an option that says flag significant correlations. That's SPSS's fancy way of saying that if it gets a statistically significant correlation, it's going to give you an indicator that you've got a significant result. Now, warning, in some tests, if you get a significant result, it will give you 1 asterisk if the result is statistically significant at the 0.5 level, and 2 asterisks if it's significant at the 0.1 level. So it helps you. It's almost like shouting at you. It's saying, if you get the asterisk, you've got significance, hallelujah. But some tests, it won't do that. Some tests, it will merely report the probability level, which I'll explain later, but it won't flag or indicate which results were significant for you in such a convenient, friendly way. So you have to know how to look at the output and determine whether or not a significant level has been reached on a test, and I'll show you how to do that in the third exciting chapter of our talk tonight. Don't worry about that now. So anyway, that's all you need to worry about. I'm not going to waste your time with options. Usually options are very specialized, careful things that people with too much free time on their hands worry about, or statisticians with not enough to do worry about, and we can get into options some other time. But all that we've done so far, to recap, is, and this is the same for any statistical test you run in SPSS, you'll see a box after you've selected the test, and in our case we selected bivariate correlation because we wanted to correlate 2 variables, gender and IQ. And then we selected which variables we wanted to run, and we transferred them from the box on the left to the box on the right. Having done that, we basically told SPSS what tests we want to run, and then we've indicated which variables we want to use. That's what we've done. We've also checked out the options, and we've decided we'll stay with a regular old Pearson correlation because this is just an example and we don't want to confuse ourselves. We will stay with a 2-tailed test of significance because there's no reason to use 1-tailed except under very special situations, and we told it, yes, go ahead and flag significant correlations. And these are the default settings anyway. We're just going to leave them alone. Any questions so far about the choices we made? Yes?
Excuse me, do we need to do anything on the options?
No. We're going to leave options alone. Most of the time, this is an excellent question. Thank you, Kenny. Most of the time, options are very unusual or special things you would do for special situations. And we can get into options more. The nice thing about SPSS, once you've learned the general way how to do it, then you can become more and more of an expert on this particular test that you need for your study or for your dissertation. And if you need to look at those options, you can then look at the options. But those are for specialized situations. I am not going to get into some advanced statistical discussion about different aspects of variance or something. But so for the most part, don't worry about the extra options, but worry about these because you would like to have as little as possible. Sometimes it will give you options here that you don't need, and the textbook will indicate to you sometimes, the extra options you don't need. So any questions about this so far? Anything else? Is there anything that's not clear? This is our great time to say that it's not if it isn't clear. Yes?
Yeah, I'm still curious about the differences between Pearson and Spearman.
Okay.
Could you explain?
Yes, I will explain.
Way?
Yeah, I will explain the difference. But keep in mind, for those of you at home, keep in mind that this is not a statistics class. This is an SPSS how to use SPSS class. So don't worry if you don't really know the difference between the two. Just keep track of which one you need to use and consult somebody like me. I mean, wherever you're listening to this, I don't care if it's in Hawaii or Ukraine, you've got to have an expert around you can ask if you need to. The question was, what's the difference between a Spearman correlation for 2 variables and a Pearson correlation? The Pearson correlation, or Pearson R, is calculated using interval data. That is, it's assuming that the data you collected was taken on scales. Each of those variables were taken on equal intervals. The Spearman correlation is just like the Pearson correlation, but it has a few differences. It calculates the correlation in a similar way, but it's different in that it uses the ranks of the observations on the 2 variables rather than the interval data. So it converts all of data for the two variables into ranks and then does the correlation. The reason why you want to use this special Spearman row, it's called, Spearman row, RHO is the way you can see it in a textbook, is if you have a situation where you have a very small data set, you might want to use it. If you have a situation where you think data are not distributed in a balanced way, you might want to use it. So those are the conditions that you might consider using a Spearman row rather than a Pearson R. Now, you don't need to worry too much about this because some tests were actually conducted comparing results of correlations for the Pearson R, we all know and love, with the specialized Spearman R. And it turns out even in small data sets, the Pearson R is very robust. So even when you have small data sets and the correlation assumptions are violated, it turns out the two tests, the Pearson R and Spearman row, can come out with very similar R's or very similar correlations. But generally, you might be asked by your committee, you might be asked by a statistician, or you might be asked by somebody because of a small sample size or skewed data to use a Spearman row rather than a Pearson R. And if you are asked to do that, you would simply check the box and get the different tests. But for this, I'm just going to keep it simple and keep it with the Pearson R. Generally speaking, the general rule is if you have 15 observations per predictor, that's enough to stay with the Pearson R. So if you have a two-variable correlation, I need to see a minimum of 15 observations to say with Pearson. Now, I know ours doesn't, but this is just an example, so we're not going to worry about it. Now we get to the exciting, fun, thrilling part. We've set up the data. We've chosen the variables. We transferred the variables we wanted. We knew it was a bivariate correlation. We transferred gender and IQ to the variables box. We checked out our options. We've discussed the options. The only thing left to do is come up over here to the OK button and hit OK. What's going to happen? It's going to run the correlation, and a new window is going to open up with the results of our little correlation. Are you ready? Bingo. Right. Don't panic. The first word that you should think about when you're doing SPSS stuff is if a strange thing happens, don't worry. It's just a machine. It can't hurt you. What's actually happened is it's looked at our correlation and it's run it. And it's popped up with a new screen called the output screen. And I'm going to enlarge that screen so you can see it. What you're going to see is, at the top, it will show you the actual code it used to run the statistic. Don't worry about that. Thank goodness we no longer need to teach people how to do the correlation or whatever test we need using the actual coding, the actual computer language, because it's a very long, difficult process to learn it and takes, when I used to teach SPSS, it would take so much longer and it was much harder, and you had to go through more steps to teach commands and teach how to do things. But now everything is menu-driven. You can do everything by choice off of menus, so it's very much easier, and I must say, it's made life easier for everybody. So don't worry about this stuff. But this part here, that says correlations, it's run the correlation for you, and this is the output. Okay? Below in this table is the output. And by the way, you should see exactly the same output in your handout for your first exercise. And when you run it yourself, you're going to get exactly the same output because I've used the same data set for this example. I'm such a nice fellow giving you a free credit, aren't I? Anyway, let's talk about the output so you know how to read it. This is another reason why I really hope that folks are able to take statistics before they take this class because, as I've said many times before, SPSS is stupid. It will run the test that you ask it to run. If it sees a major problem, it might give you an error notice. But generally, it will simply run the test you ask it to run with the variables you've indicated and give you the output and say, there it is. Now it's up to you to interpret it. And I'm going to help you interpret this so you know how to interpret the output from an SPSS output file.